The transfer function can be any transfer functions can be used here. We have so many transfer functions, and most commonly used transfer functions, if you see here, the functions, activation functions, are nothing but hard limit activation function. So here, what will be the positive values? All the positive values will be taken if your output A, that is after multiplying W with P and then adding with bias B, and if your value N is going to be a positive value, it will be limited to +1, and if your N is going to be a negative value, it will be assigned to 0. So this is one of the activation functions, okay, because we are going to threshold it. So we are doing a threshold, and accordingly we are going to generate the output. So say for example, if sepal width, if I say the width and length are going to be somewhat linear, then I'll say it belongs to one category of the flower, one family of flower. And if it's going to take some other value, I'll say that it belongs to some other family. So which means that I have to have a thresholding function here. So this activation function is nothing but is a thresholding function. So other linear transfer functions we have here is a linear transfer function. So here N is the output. So if N is going to be a positive value, and if N is 0, A is also 0, output is also 0. If N is 1, output is 1, and so on. And here again, either we can limit it or we can have N, it's a linear function actually. And then the next one is log sigma transfer function. Most cases you'll be using this this transfer function in back propagation networks. So if you see here, if it is positive value, if N is going to be positive value, it will take a log sigma of N. So it will take a log sigma value, and then if it is N is going to be a negative value, then the graph is going to be something like this. Okay, so these are the different transfer functions or activation functions we are using. And see here, this is how one neural network looks like, a simple with vector input. In the previous case, we have taken a scalar input where we have only one value, one input, scalar, only one input, and then one layer, and then one output layer, one hidden layer, one output layer. So if you see here, the neuron with vector input, which means that it is of different dimensions. So only one input here, but one input of size 1, it's P1, P2, PR, which means that it's R element input vector, single R element input vector. So only one input. So I'm taking what to say, only one feature here, and one feature is going to have 6 different elements. So this is what is your input is, and this is for neuron again. So each and every input is being given to that what to say, the hidden layer with some weight values. So here the weight differs for each and every P1, P2, P3 elements. And here if you see, it's W into P plus B again here, and some activation function will take over here. So capital R is the number of elements in the input vector.